Welcome everyone to the podcast of Gas Pathways, a new multimedia communication platform dedicated to innovation and technology in the natural gas industry. Today I am joined by Stephen Luer, CEO of Unitrove, who is looking to make the case for using liquid hydrogen as a zero carbon fuel in shipping. Stephen, glad to have you here.
Thank you very much, Joseph. Pleased to be here.
So there is far more attention on the use of compressed hydrogen as a fuel to reduce shipping emissions, whereas I've seen relatively little interest in liquid hydrogen. Why do you think that is the case?
Yeah, I think with the compressed hydrogen route, it is one of the more sort of easily or handleable type of fuel. It's a bit more accessible for those in the industry that understand sort of gases and things like that. Once you start moving into something like liquid hydrogen, you're also now then dealing with handling a cryogenic. So liquid hydrogen being liquid at minus 253 degrees Celsius is something that makes it a lot more challenging for those that don't really have that understanding of how to handle cryogenics. Much more difficult, I think, yeah.
And firstly, how truly net zero would the fuel be? And can we maybe talk about what kind of costs would be involved in developing it? Do you envisage using green hydrogen as you know and then liquefying it?
Yeah, so again, you know, this opens a massive debate that I'm sure many that are in the industry sort of understand. There's this whole big debate about hydrogen and the way it's being produced. Obviously, we can talk about green hydrogen, the idea that we want to produce hydrogen from renewable sources of electricity. And then, of course, we've got the case for the blue side, where we're taking natural gas and maybe reforming that and capturing the carbon through CCUS. And if we look at the complexion of the hydrogen today, we can't get away from the fact that the vast majority of it is made from sort of fossil sources, probably over 90% plus, and none of which is actually done via carbon capture storage, which is where the blue hydrogen movement wants to go in. And if we then look at liquid hydrogen specifically as a market, there are very few players today that are able to produce liquid hydrogen. You're talking mainly to the industrial air gas companies who, as I say, have been serving the industries such as the space sector, for example, that might require liquid hydrogen as a rocket propulsion, or some of these other fringe industries like your semiconductor industries, where there's also a use case there. So in terms of the actual production of sort of green liquid hydrogen, it's not really been something that many companies have been looking at or right now, and up to this date have been sort of working on, mainly because there's never really been a need. And even for these fringe industries like the space sector, like the semiconductor industry, you know, they're lucky in that sense, or they would say so, to even just have somebody who's prepared to produce that for them. It's such a niche industry that there isn't much need to actually produce large quantities of it. Obviously, that's going to have to change going forwards if we're going to talk about moving towards a net zero future by 2050. And as we start to see the pathways like into planes, trains, ships, which is obviously where we're focusing on as a beginning point, and we can come to the reasons why in a bit, but there's going to have to be a radical shift. And for us, yes, of course, we would love to produce liquid hydrogen from green sources. That will be our ultimate ambition. The pathway to getting there, of course, is going to be challenging. Certainly in terms of the fact that we're trying to deliver this infrastructure piece by this year, hopefully for the COP26. We need to obviously find some way of being able to commission that system. So we're going to have to look and see how we're best able to do that. And obviously going forwards, once the vessels start coming in, we can start preparing to make the business case and make those investments as and when we need to.
Hmm. So you will be using cryogenic technology. So your company's experience comes in handy then, because you've also in LNG. I mean, you were also behind building a LNG bunkering facility in North England.
Correct, that's right. We in fact actually built the UK's first LNG bunkering facility in the Teesside area, which quite fascinatingly is actually quite a politicised area at the moment. And back in 2015, it was a very interesting experience for us, because historically we'd actually been doing a lot of work with LNG as a use for road fuel. And much of the developments that we had done was for building fueling stations for heavy duty trucks and buses and things like that, not just for LNG, but also with compressed natural gas as well, CNG. And so we've actually been involved in the natural gas space for quite a number of years, well over a decade, and our experience goes beyond that. But I think that is one of the main reasons why we see hydrogen as a very promising pathway going forwards, because a lot of the hydrogen technology today is built upon the foundations of natural gas. If we talk about compressed hydrogen, for example, a lot of the technologies for that has come from the compressed natural gas space. And likewise, now we're moving into the liquid hydrogen space. A lot of those technologies are birthed from the liquid natural gas space. And so I see that the way forwards is not by throwing away the understanding of how these technologies work, but actually building upon those and using them in the right way that we know that we can. And I think the LNG world has shown us what is possible of what the future could hold for something like liquid hydrogen.
And your technological concept, as we said, there's not that many companies looking into liquid hydrogen, at least as a shipping fuel. But how does your concept? How would you differentiate it from similar concepts?
Yeah, so maybe the LNG bunkering facility that we delivered to Teesside in 2015 is a very good example to start. And I think also it's quite interesting if you speak to the shipping companies that some of them will also see LNG as a relatively new prospect for them as well, especially since they're very used to the heavy fuel oils, marine gas oils, the very traditional petrochemical products. So even for them, LNG is quite a unique product to handle. But if we look at the way that we delivered the system there, it's a relatively what I call small or nanoscale type unit. And it's a unit that's self-contained, and ultimately you can bring it to the port side. It's not a permanently fixed piece of infrastructure like a lot of people might think in terms of the way of a traditional piece of infrastructure, but you can literally drop the box in, plug it up, and you're up and away. And if that facility at the future needed to be removed, you could just disconnect the connections and move that unit away. And it's actually smaller than some of these other containerized type units. So some people might be building facilities in a sort of a 40-foot container. This would be probably smaller than a 10-foot type sort of size footprint. So this is a very small scale product, but not just that. In the way that we delivered the infrastructure there, the storage for the fuel is actually also mobile as well. So the idea was that we'd take these 40-foot ISO containers, they would be loaded with the LNG product in this case, and they would be brought to the port side, and there it would actually be connected to our system, and then our system would then connect to the ship that it needed to be fueled, and then the product would be offloaded via our system. And once that transfer had been completed, then those mobile storage units could actually be taken away, which is really useful because that means that there's no sort of permanent storage of flammable product at the port side. It's basically brought in as and when that fueling needs to happen and offloaded and then taken away. And so that makes it a lot easier for example, the ports and things like that to they're a lot happier with this kind of arrangement, because it means that there's no complications in permitting issues or in the idea that they're going to have to look after permanent storage of flammable products, which maybe then goes into what we call the COMAR regulations and things like that. And the ports are not really, it's not really their kind of expertise to have to look at those kind of things. So we see something very similar in the way that we want to deliver liquid hydrogen. Again, by looking at bringing containers of this product in and connecting it to the system and offloading it and basically moving these containers away. Now, that actually contrasts with what some in the industry call truck to ship fueling, where basically they bring a road tanker with the product and they connect a hose across to the ship and they simply connect. And that's fine to some, in some respects. It's a very traditional way that bunkering operations for your petrochemical, your typical heavy fuel oils, marine gas oils are done. But one of the things that is missing from that jigsaw piece is the safety factor. For example, I'm bringing my expertise back in from the road transport industry, where the big questions were, well, if we've got a big storage of flammable product, how far should that tank be away from the vehicle so it's fueling? And likewise, should we not be asking the same question for a big, large ship and a tanker? I mean, could we expect to see maybe separation distances between the road tanker and the ship? And I think a lot of people are missing that question, and not just that kind of safety factor, but also the fact that our unit will contain additional safety features like gas detection, like breakaway couplings in case a ship drifts away and things like that, like ESD systems where, for example, if the ship wants to shut down the shore side or the shore wants to shut down the ship side, we can do that, and that's all done with our box basically.
And you've proposed building this liquid hydrogen bunking facility. Do you have an idea of the project site? I mean, you're planning to showcase it at the UN climate conference, right, in November. So yeah, do you have a project site in mind? Have you had any initial talks with authorities, with investors about this scheme?
Yeah, I mean, of course, we put our press release out not massively long ago, and already that's given us quite some new leads as well in terms of our project. And actually, when we built this facility, of course, we've got experience with the Teesside area. We know that's heavily politicized, especially in terms of the idea that these are sort of areas that are typically forgotten in this kind of new age of technologies and things like that. So of course, they're also on the radar. But of course, we've had many other organisations, ports, not just in the UK, but also globally as well, that has had sort of an interest in what we're doing. And actually, when we set about this project, we didn't necessarily think about who the end user was necessarily going to be. And if I'm honest, we haven't lined that up yet. But what we could see was a lot of movement that's happening globally. I mean, if we look, for example, to Norway, for example, I believe that they've already received one of the first liquid hydrogen powered ferries, and they look to be operating that on liquid hydrogen as early as the beginning of next year. And of course, these announcements would have been made some 2-3 years ago on the onset of the project, because obviously it takes time for these vessels to be built. And already I know Norway again is a leading area where there are other announcements, whether say by 2023 or 2025, there are new vessels that are coming in already. And of course, these projects take some 2 years, 3 years to go through that process. So what we wanted to do was to make sure that once we built this thing, we would be basically in and around the same time as when these vessels were also coming out as well. For us, it didn't quite make sense to wait until these vessels were there and then build the infrastructure, which would add then some additional years. The idea was to kind of almost beat that chicken and egg problem by trying to say, okay, as these first hydrogen vessels are coming out, so the infrastructure is also matching, and that is coming out at roughly around the same time. And I think hopefully by us being able to showcase the technology for the infrastructure side this year, and the early fuelings happening maybe at the beginning of next year, at least in some parts of the world, then hopefully we see there's definitely a pathway forwards in terms of where our system can go. Certainly we've had inquiries from California as well, We know that places like Korea are working on these kind of technologies quite strongly as well. So there's a whole host of opportunities out there. So we have no worry from that kind of point of view.
Mm-hmm. Yeah, the chicken and egg problem is always, a challenge. When you're developing a new energy source. I mean, we've seen that problem we've seen that challenge come up with developing LNG as a fuel and shipping initially in some markets, and also using LNG in trucking. This project's at a very early stage of development, so I understand that it can be difficult to say when you might commission it. But do you have a rough schedule in mind? What would you like to achieve?
Well, as I say, I think the COP26 climate change conference will be a good starting point for us. Hopefully we'll have a physical demonstration unit there. They can, people can then look at it and see it, and then it's kind of translating out from a piece of paper to something that actually is physically tangible. And what's fascinating is the fact that liquid hydrogen is not, although it's new for the industry, it's not a new technology. As I've said to some people, we've been using liquid hydrogen to send rockets to space since the 1960s. And actually, a lot of the technology that is going into our system is derived from that industry. We're using sort of couplings and valve technologies that are stemming from these industries that have long tested these units and understand it. And so it's not the case that we don't understand how the technology works. It's the case that we're actually now trying to bring these technologies into a new application area. So if we're able to fuel rockets since the 1960s with liquid hydrogen, I don't see any reason why some many decades already down the road we can't be using the similar technologies to be doing the same thing for ships. It's not as challenging as people think it is.
Yeah, absolutely. Okay, and as a company with a footprint in LNG bunkering, but also looking to evolve your business into and branch out into liquid hydrogen fuel, how should we treat LNG as a solution to decarbonising shipping? So we have a situation now where still the vast majority of ships are running on fuel oil, and the IMO regulations have obviously improved matters, but there's still a lot of work to be done to decarbonise shipping. Some will argue in the LNG industry that all focus should be on expanding the use of LNG. But it's a product that's ready now. You've got the supply, the infrastructure is developing, and focus less on future fuels like hydrogen, like ammonia, and on the other side, others say, well, focusing on LNG, that locks in gas demand for much longer, and it will kind of prevent the deployment of these new fuels. What's kind of your view on that?
Yeah, I think for me it's a very interesting, hopefully I'm able to provide an interesting perspective, not least because actually I've spent the past decade or so in the natural gas industry. So I completely understand where those who are advocates for LNG going forwards now starting to see the first signs of the green grasses, especially in the maritime sector, where now they're saying, oh look, we're starting to see more and more LNG vessels. It's starting to grow. There's big traction. Yes, I understand that, and especially with the fact that also I've committed quite a lot of time to the development of international standards and regulations around LNG fueling technologies and things like that as well. So I completely appreciate that, but at the same time, I also appreciate the fact that there are these new technologies out there, and they are gaining some traction. And we do have to move towards a world where, if we want to achieve net zero emissions by 2050, then we should have to try to use everything that we can and know to be able to achieve that. So from our perspective, we don't settle on a technology. We're all about enabling possibilities. And actually, some may say, oh, well, who are you to kind of push this new renewable hydrogen movement? You've been spending a decade long in the natural gas world. Well, I can't hide that. No, I'm not going to hide that either. But I would say that had it not been for my experience in the natural gas industry, I would not have been presented the opportunity to see what would be possible with the decarbonising of shipping. It was when, as I said, we were traditionally involved in the development of refueling of heavy-duty trucks and things like that, and it just landed on our desk that, oh, by the way, there's a company that's interested in LNG fueling of ships. Is this something that you could do? And we said, well, trucks, ships, is there much difference? Probably not. Okay, let's just apply what we know to a new situation. And here we were moving from fueling of trucks to fueling of ships. And then we realized that actually the amount of quantities of fuel that shipping takes in relation to sort of your trucks was magnitudes of difference. I used to stand there thinking, oh, how many trucks do I have to fuel in order to do the equivalent of a single ship? And these were two vessels that were coming in twice a week, taking up to 50 tons of product at a time. So I think that the LNG industry needs to think about, and of course I know that there will always be two sides of the coin, but at least from my perspective of LNG, I feel kind of blessed to have understood what the market was all about, what the customers actually really wanted, and also built that expertise up that LNG actually provides. LNG, for example, is still a cryogenic fuel, minus 162 degrees Celsius. It's flammable. Yes, maybe not quite as flammable as hydrogen, but it sets the pathway for starting with this expertise and building on top of that. And actually, if I think about the involvement of standards that I'm now involved in with the hydrogen technologies, a lot of the standards are built upon other existing standards. So the hydrogen technologies will go, hey, what natural gas fueling standards have we got? And what can we use that as a starting point to build our hydrogen fueling standards? And the same way for liquid hydrogen, they'll say, hey, can we use these LNG standards as a starting point to be able to then develop liquid hydrogen standards? And so for me, it's more a case of less focus on the technology and more about the possibilities. And I'm not here to say that liquid hydrogen is the future, because I can't know that. Maybe someday it will be ammonia. Maybe it will be one of these other things, like I know in the industry they talk about liquid organic hydrogen carriers, and even things like sodium borohydride, solid hydrogen. There's so many innovations that are going on. I mean, and of course we can't discount the other side of the coin, which is electric and battery technology, which of course will still progress. And people are talking now about flow batteries and things. And as a company, we don't see ourselves as trying to pigeonhole ourselves into specific technologies. We just want to see what the possibilities are, and we want to use our expertise going forwards to support that.
I see. And how would you characterize the approach of the UK government to these future fuels like hydrogen? How supportive are they?
I've been lucky to kind of be involved in some sort of groups quite close to the government in terms of their policies for the energy transition, especially in the hydrogen space, where that's a very hot topic, especially for the government at the moment. I mean, I know the UK government has been badgered for a very long time to release their national hydrogen strategy, and they've only done so very recently, even though other countries had had already delivered theirs maybe some number of years ago already. Personally, I read it and I didn't feel that there was much volume to that hydrogen plan. I think it was just a lot of rehashed possibilities. They talked of grants that they'd already sort of delivered and things like that. The other insight that I can kind of provide is that whilst we can see in the media, for example, already people are debating about does blue hydrogen make any sense? Is it just propping up fossil fuel companies, or should we be going down the green road? And the UK government has taken a very firm stance to say, actually, we back blue hydrogen as well as green hydrogen. But because they know that there is potential for negative press on the blue hydrogen, actually the UK government, they don't actually want to refer to hydrogen by way of colour. So they will try to avoid the use of the terms green hydrogen and blue hydrogen, and they would much prefer to talk of low carbon hydrogen. And that's a very interesting narrative. I think if I'm giving my personal view on this whole net zero by 2050, one of the biggest things that's missed from this conversation is it going to be done renewably, or is it going to be done non-renewably? Because I think a lot of people are saying, hey, yes, of course we can achieve zero emissions by 2050, but maybe the mechanisms by which we're doing that is not necessarily renewable. And I think that's where there's this whole big dilemma and battle from the one side and the other. They're saying, no, this way is the way to do it. No, this way is the way to do it. And I think that narrative of just simply saying, well, it's all about eliminating carbon emissions is the end objective. But some people don't like the way that how that has been done. I think one of the arguments I have taken to some people is, imagine we had a technology where we could capture the world's carbon, like we could capture all the carbon in the world, but does it then make it right to continue to burn coal? People would say, well, you're still in a net zero outcome, but some people don't like this idea of doing it in a way that is not seen to be a sustainable one. So I think that is, blue hydrogen in some way is a lighter version of that, but if we take it to that extreme, that's almost what we're kind of saying.
So you agree with the government's approach, being technologically agnostic, and balancing green and blue hydrogen. I mean, it contrasts with the European Commission's approach, which is very much slanted in favor of green hydrogen, at least as the end destination, right? And they see blue hydrogen as more a short to medium term solution, especially for just changing the existing grey hydrogen supply and making it clean.
Yeah, I mean, of course, there's one thing about setting an intention to do things and setting the ambitions, and of course, all countries around the world are going to have a different view on the way to go. Obviously, the UK government has decided to back a twin approach, as I say, maybe they'll call it a more agnostic approach, and as you say quite rightly, that the EU is focused on a more green approach. Certainly, I am much more in favour of taking that green approach, but having come from a natural gas background and understanding a lot of the complexities around the energy space and the reasons why there is this lobby for blue hydrogen, I can appreciate why governments, for example, like the UK government, would want to support that. You couldn't throw out a whole industry and expect that something's going to fill that void. That's just far too risky for the government's point of view. So I think it's a very complex question, and it's very easy to be on one side of the coin and say, hey, we should go completely green. But then the reality is that if we talk about hydrogen, 90% or whatever it is from fossil sources. How can we ramp up the green production of hydrogen, especially with the economics and everything else, which again, I appreciate the term of cost always comes back into this equation. And so if I'm to respond to the point about cost, I think, again, the pushback from sort of the kind of the blue hydrogen industry is always, but how much is it going to cost? We can do it more cost effectively. And I would always say, but it's all well being cheap or cheaper or cost effective, but maybe one day that cost effective fuel will be banned, and therefore you can't use it. So it doesn't matter how cheap your fuel is, it just won't be a viable option going forwards. And that's something that we kind of suggest to some of the companies out there that are saying, well, what's the economics of this? How's it going to work for us? And we can see how the global politics around energy is moving towards this green transition. People can argue all they want about, oh, we don't like the fact that government's giving subsidies to these areas, or that they're applying these levies and things like that. But these things will happen. We have to accept that this is going to happen. And anybody that is going to reject that possibility, I think, is going to unfortunately see their kind of case move by the wayside. And we've seen many examples of that happen. So I think everybody has to understand the political framework around which we talk about energy, and to think what is the sensible option. And in my mind, the only way that the world is going to move forward is towards these lower carbon options, towards a zero carbon option, and they will do everything possible, whether technologically or whether economically, whether that's applying even greater carbon taxes, whether it's banning certain types of fuels, or whether it's subsidizing certain technologies. These things are going to happen, like it or not. And I think we just have to pay close attention to that. And people are then free to decide which camp they want to be in.
Well, very, very interesting discussion. And I look forward to hearing more from your company in November then. Any closing remarks, Stephen?
No, I'd just like to say thank you very much for the opportunity for me to be able to talk about our technology. And if anybody has any more interest in what we're doing in terms of liquid hydrogen or compressed gases hydrogen, then by all means, feel free to get in touch.
I'm sure they will. Thank you for tuning in to the podcast of Gas Pathways, a new multimedia communication platform dedicated to innovation and technology in the natural gas industry. See you next time.